This is section 8.1, day 2 in class. The amount of water in a storage tank in gallons is modeled by a continuous function on the time interval 0 to 7, where t is measured in hours. In this model, rates are given as follows. 1. The rate at which water enters the tank is f of t, and it's the curve. So the curve is water entering the tank, the rate at which water enters the tank. Number 2, the rate at which water leaves the tank is the piecewise functions. And from 0 to 3, we have 250 gallons per hour. And after 3, it's 2,000 gallons per hour leaving the tank. The graphs of F and G, which intersect at t equals 1.617 and 5.076. So there's the 1.617. This is the 5.076, are shown in the figure above. At time t equals 0, the amount of water in the tank is 5,000. So the amount at time 0 is 5,000 gallons. How many gallons of water enter the tank during the time interval 0 to 7? Round your answers to the nearest gallon. So we just have to integrate from 0 to 7 of f of t dt, because that's the rate at which water is entering the tank. Now, I've already put that function into y1. I've put the piecewise function into y2 and y3, and you can actually graph piecewise functions by using the test symbols there right here in test. So you have the equal, not equal to, and so on. So we're going to go math number 9. We're going from 0 to 7 because the question is how much water enters the tank, ignoring how much is leaving the tank. So then we can go variables, y1. We're integrating with respect to x on the calculator. And the answer is 8,263.806 gallons. For 0 to 7, find the time intervals during which the amount of water in the tank is decreasing. Give a reason for each answer. Well, here, this out is more than in. So the overall rate is actually negative here. Then these switch places. So the overall rate now is positive. The tank's now beginning to fill up. Then they switch places after 3 hours. So now the overall rate is negative, and then the overall rate ends being positive. So find the time decreasing. So the overall rate is decreasing. So we can say that, well, g of t is greater than f of t from 0 to 3, and then again from 3 to, oh, not 0 to 3, excuse me, 0 to that 1.617. 0 to 1.617. And then they switch again, negative is more than positive, or out's more than in, from 3 to the 5.076. For 0 to 7, at what time t is the amount of water in the tank the greatest to the nearest gallon? Compute the amount of water at this time and justify your answer. So we know that a of 0 is equal to 5,000 gallons. And then we want to know local maximums and decide where's the overall maximum. So a local maximum can be right at 3 because the rate changes from positive to negative there. So there's going to be at least a local maximum. So a of 3 is equal to 5,000 plus the integral from 0 to 3 of in minus out. And we want to actually, we know the out because it's constant. It didn't change. So here's the in, that does change. So we want to integrate that. But then minus 3 hours times 250 gallons per hour. Then we want a of 7 because it's the other endpoint. It could be a local maximum. So we're going to take not 5,000. We're going to take the answer that we get for a of 3, and we'll continue on to the endpoints. We're going to take that answer that we get for a of 3. That's going to be the a of 3 answer plus the integral from 3 to 7 of f of t dt minus now 4 hours from 3 to 7 times 2,000. So we're going to minus 8,000 gallons from that answer. So let's go with 5,000 plus the math, number 9, and we're going from 0 to 3 of f of t. So we have variables, y1 with respect to x, but then we're going to minus 3 times 250 from that. So we get 5,126.590 gallons. So that one's definitely in the lead now for the maximum. But we're going to take that answer, 5126.590. But we're going to use the number in the calculator. We're going to add math number 9, 3, 2, 7 variables, y variables with respect to x, but then we're going to minus 8,000 from that. Whoops, missed the minus. Insert minus. There we go. That one is 4,513.806 gallons. So to the nearest gallon, compute the amount of water at, let's go, at 3 hours. The tank has the maximum amount of water, 5,126.590 gallons. Let's look at the rubric very quickly. There's 8, did it say to the nearest gallon? Should I have been doing that? To the nearest gallon. So we would say, rather than this, we'd go 5,127 gallons. How many gallons around your answer to the nearest gallon? I should have had 8,263 gallons, 64 gallons. There we go. Now I fixed it a little bit. Yeah, so the rubric says 8,264 gallons, one from the integral, one from the answer. The amount of water in the tank is decreasing on intervals 0 to 1.6 and then 3 to 5.076 because f of t is less than g of t. I made the exact same argument. Since f of t minus g of t changes signs from positive to negative, only at t equals 3, the candidates for the absolute maximum are 0, 3, and 7. That's endpoints, and then the one candidate in the middle. So 1 identifies t equals 3 as a candidate. 1, I have the integrand. That's actually writing this right here. One amount of water at t equals 3, and then the one at t equals 7. And then finally writing a conclusion, writing the answer. The function g is defined and differentiable on the closed interval -7 to 5 and satisfies g of 0 equals 5. The graph of y equals g prime of x, the derivative of g, consists of a semicircle and 3 line segments as shown in the figure above. Find g of 3. So g of 3 is equal to, we're going to go 5 plus integral from 0 to 3 of g prime of x dx. And that's equal to 5. We're starting at 0 and we're going to 3. 1, 2, and 3. So we have a quarter of a circle. 1/4 of pi times 2 squared. The radius is 2. And then plus this triangle right there. So plus 1/2 times 1 times 3. So we have 3 halves plus 10 halves. That's 13 halves. 13 halves. And then plus pi because the 4s are going to cancel out. And then g of -2 is equal to, we're going to start with 5 plus the integral from 0 to -2 of g prime of x dx. And that's going to be 5, but then we're going backwards, aren't we? 0 to -2, so 5 minus 1/4 pi times 2 squared. And so that answer ends up being just 5 minus pi. Find the x-coordinate of each point of inflection of the graph of y equals g of x on the interval -7 to 5. Explain your reasoning. So we're finding the points of inflections of g. So we need to know where g goes from increasing to decreasing, but this continues to increase. All right, increasing to decreasing right there. So we have x is equal to 0 because we're going increasing to decreasing. We also go from increasing to decreasing at x equals 3. So we say that g prime of x changes from increasing to decreasing. And then x equals 2, g prime changes from decreasing to increasing. So that's where we have points of inflection. The function h is defined by h of x equals g of x minus 1/2 x squared. Find the x coordinates of each critical point of h, or -7, where we go from -7 to 5, and classify each critical point as the location of a relative min, max, or neither a min nor a max, and explain your reasoning. So let's take the derivative. H prime of x is equal to g prime of x minus x. So we want to set that equal to 0 because we're finding critical points. So if we add over x, we want to know where g prime of x is equal to x. Well, that's like saying where is the x equal to the y on this graph? Well, x is equal to y on the line y equals x. Right there. So we have a point here and the point 3, 3. So we have critical points at x equals, well, 3 for sure. But then what about this other one? Well, that's a 45-degree angle. So if we were on the unit circle, that point would be square root of 2 over 2, square root of 2 over 2. So this one just happens to be 2 times the square root of 2 over 2 because the radius is 2. Well, those cancel out, so x is equal to 2. So we have critical points of 3 and square root of 2. Well, now let's go back to this spot right here. H prime of x is going to be positive when g prime is bigger than x, and h prime of x will be negative when x is bigger than g prime of x, because you'd have a small minus big is going to give you a negative answer. Well, let's say from 0 to the square root of 2, the x value is going to be smaller than the y value. So we're going to go from, let's see, g prime is the bigger, so that'd be positive. We're going to go from positive to negative over the square root of 2. So positive to negative, that's a maximum. So we have a maximum there because h prime of x changes from positive to negative. But then x is always going to be bigger than g prime of x from square root of 2 all the way to 5. So we're going to say neither, because h prime of x never changes signs. So there we have one uses g of 0 is 5, one g of 3, and finding the value for g of -2. So one for using the fact that we're starting out with 5. The graph of y equals g of x has points of inflection at 0, 2, and 3 because g prime changes from increasing to decreasing. And then g prime changes from decreasing to increasing at x equals 2. One for actually writing h prime of x is a g prime of x minus x. Identifies the two places where g prime or h prime of x is going to be 0. Answer for square root of 2 where you have a maximum at square root of 2, and answer for 3 with analysis saying that at 3 there's neither at that value.